Hello everyone, today we're going to solve the fifth question of the 2024 CCC Senior Contest. It is called Chocolate Bar Partition. So we would like to know what the maximum number of connected parts. We can split this 2 by n chocolate bar in two so that each part has the same average tastiness. In this problem, we need prefix sums and dynamic programming. Before diving into this problem, let's first talk about prefix sums. Let's look at a simple example array and show how to calculate its prefix sum. So the first number is 1, so we're going to put that into the prefix sum. The next number is negative 2, so we're going to add that to the 1 in prefix sum. So now it's negative 1. Then we're going to look at the next number, which is 1. We add that to the negative 1 in prefix sum, so now it's 0. The next number in A is 1, so then we add that to the number in prefix sum, which is 1 now. The next number in A is 4, so we add that to the 1 in prefix sum. Now it's a 5. So if the prefix sum at two different positions are the same, the summary in between sums to 0. For example, if the prefix sum at index 0 is 1 and the prefix sum at index 3 is also 1, then the numbers from index 1 to 3 add up to 0. As you can see, negative 2 plus 1 plus 1 equals 0. Noticing the same prefix sum at different points is a quick way to spot subarrays that sum to 0. We'll use that trick to tackle the problem more effectively. Okay, now let's look at the test example from the problem. N is 5, meaning we have a 2 by 5 grid of chocolate. First, we're going to multiply each number by 2n, so we can avoid any fractions when we do our calculations later. For the previous table, the sum is 10, so the average here is also 10. Because we multiply each cell's value by 10, and we're treating the average as a spaceline. Now we calculate its prefix difference, which is a form of prefix sum but applied to element minus average. For every number in the first row, we subtract 10, which is the average, then we keep adding those results to prefix difference PSA. So the first number is 10. 10 minus 10 is 0. And then the next number is 0. 0 minus 10 is negative 10. The next number is 10. And 10 minus 10 is 0, so we don't change anything. The next number is 20. 20 minus 10 is 10, so we add 10. The next number is 0, so 0 minus 10 is negative 10, so we subtract 10. This way, PSA tells us how far above or below the average of the first row is as we move from left to right. For every number in the second row, we're subtracting 10, but instead we add it as a negative. So the first number is 0. 0 minus 10 is negative 10, but we're adding its negative, so it's 10. The next number is 20. 20 minus 10 is 10. And we're adding its negative, so it's back to 0. So the next number is 0. 0 minus 10 is negative 10, but we add its negative, so it's 10 again. The next number is 30. 30 minus 10 is 20, but we add its negative, so now it's back to negative 10. The next number is 10. 10 minus 10 is 0, so we don't change anything. By taking the second row as negative, if PSA and PSB become equal, that means the first row's offset and the second row's offset perfectly balance out, summing to 0. This is super helpful for deciding how we slice or count segments in the problem. Then, we'll use dynamic programming to remember with these prefixes difference and get the best possible solution. We'll use a dictionary called DP. Its keys are the value of PSA or PSB. Its values are the best score or the number of segments we can achieve whenever that prefix difference appears. We start DP with 0, 0, and set the initial value of as to 0. Next, we look at the first column. PSA is 0. We check if 0 is already in DP. If it is, we add 1 to whatever score we had for that key. If it's not, we start from 0. So here is 1. Then we compare 1 to the current as, which is the global best, to make sure we don't go backward. Now DP0 is 1, indicating that at this point, it is possible to separate a piece of chocolate that satisfies the average value, like this. Next, we look at PSB, which is 10, and handle it the same way. Since DP doesn't have 10 yet, we set it to 0. Then compare that to as and keep the larger value, which is still 0. Now DP has 2 keys. Finally, we take the bigger of DP0 and DP10 to update answer, giving us a global best at this position. Then we look at the second column. Here, PSA is negative 10. Since our DP dictionary does not have the key negative 10 yet, we set DP negative 10 to 0. Then compare 0 with our current answer, which is 1, and keep the larger value, which is still 1. Now dp has 3 keys in it. dp negative 10 is 1. Next, we check PSB, which is 0. Because PS0 is in dp, we add 1 to the existing value, making it 2. Then we compare 2 to the current answer, which was 1, and update dp0 to 2, since that's bigger. Now dp0 is 2, meaning at this point, we can split the chocolate into 2 parts that both match the average value, like showing 2 valid segments. Finally, we compare dp0 and dp negative 10 to pick the higher one, which remains our new answer of 2, the global best at this stage. Then we look at the third column. Here, PSA is negative 10. Since negative 10 is in dp, we add 1 to the existing value, making it 2. Next, we compare 2 with our current answer, which was 2, and update dp negative 10 to 2. Now, both dp negative 10 and the answer are 2, so we have 2 different ways to split the chocolate up to this point. Next, we check PSB, which is 10. Since 10 is already in dp, we add 1 to its pre-existing value, making it 1. We compare 1 with our current answer, which was 2, and update dp10 to 2. At this moment, dp10 also remains 2, carried over from our current answer, so the splitting method stays the same as before. Finally, we compare dp negative 10 and dp10 to pick the higher one, which is still 2. Notice that by the third column, there are 2 possible ways to split, both recorded in dp. Then, we look at the fourth column. PSA is 0. Since 0 is already in dp, we add 1 to its current value, making it 3. We compare 3 to our current answer, which was 2, and update dp0 to 3. Now dp0 is 3, meaning we can split the chocolate into 3 pieces, matching the average like this. Next, PSB is negative 10. Since negative 10 is in dp, we add 1 to its current value, making it 3. Then, we compare 3 with our current answer 2, and set dp negative 10 to 3. At this point, we can again form 3 pieces matching the average. Finally, we compare dp0 and dp negative 10 to pick the larger one, which is 3. Notice that by the fourth column, there are also 2 ways to achieve 3-piece splits, and both are recorded in dp. Now we look at the last column. PSA is negative 10. Since negative 10 is in dp, we add 1 to its current value, making it 4. We compare 4 with our current answer, which was 3, and update dp negative 10 to 4. Now dp negative 10 is 4, meaning we can split the chocolate into 4 pieces matching the average like this. PSB is also negative 10. Again, negative 10 is in dp, so we add 1 to its current value, making it 5. Then, we compare 5 with our current answer 3, and set dp negative 10 to 5. At this moment, we can form 5 pieces that meet the average. Because both PSA and PSB are negative 10 here, dp negative 10 holds our final result. Notice we've been using the prefix sum principle throughout to figure out how to split the chocolate into these average matching segments. This is a code in Python 3. As you can see, it passed all test cases. And this is a code in C++. As you can see, it also passed all test cases. Thank you for watching.